Hi and welcome everybody. In this video we are going to be talking about a novel data transmission method called multiple MIMO system with antenna number modulation. In order to come up with this data modulation scheme, we combine two schemes, the massive MIMO and the antenna number modulation together. So the massive MIMO comes with a bunch of advantages like multi-user service, spectral efficiency, channel reliability because of the diversity gain, low propagation loss. These are some of the advantages of the massive MIMO. But on the other hand, massive MIMO comes with some of the disadvantages, like the cost that comes with the hardware and the signal processing. Also, the radio frequency chain complexity is one of the other disadvantages, and interchannel complexity. These are the disadvantages of the massive MIMO scheme. And the other modulation technique that we are going to be deploying the multiple MIMO-ANM system is the antenna number modulation. The advantages of this data transmission method is additional bit transmission by the antenna numbers, and the spectral efficiency, and channel and data dependent antenna selection. This is one of the most important advantages of the antenna number modulation, by the way. And the antenna number modulation also provides low complexity. But on the other hand, the disadvantage of the antenna number modulation is the low additional data bit transmission under a small number of antenna containing systems. So we are aiming here to get the advantages of both massive MIMO system and antenna number system and come up with a new data transmission scheme called the multiple MIMO-ANM. So let's see the system model of the multiple MIMO-ANM scheme. Now consider a bunch of bits, we call them incoming bits. We will separate them as the block number bits and antenna number bits. These two will decide how many blocks we are going to be used and how many antennas in each block we are going to be used. The purple rectangles are the blocks, and each triangle here, these are the antennas. So we decide by the incoming bits how many antennas and how many blocks will be activated, and we're going to be transferring the additional data bits by the feature of the M-MIMO-ANM scheme. So in order to do that, we have a mapping table here. Basically, if the group that we decide here consists of 0, 0, it means we're going to be activating only one block here. Like if this 2 bits here is 0, 0, we are going to activate only the B1. And if it is 0, 1, we are going to be activating the two blocks. And if it is 1, 0, we are going to be activating 3 blocks. And if it is 1, 1, we are going to be activating all the 4 blocks. Like if it is 0, 0, B1 is active here. If it is 0, 1, B2 is active here. And B1 and B2 is active actually, sorry. And if it is 1, 0, B1, B2 and B3 will be activated. And if the block number bits are 1, 1, we are going to be activating all of the blocks. Similarly, the ANM mapper works in the same way, but for the antennas in each block. So the ANM bits are 0, 0, then we activate only one antenna in the activated blocks. Like, let me explain it in this way. If it is 0, 0, this one here, it doesn't mean that we are going to be activating all the one antennas in each block. We decide first how many blocks are active. For example, it can be only the B1, and we activate the one antenna in the activated block. We'll see that in the following examples. And if it is 0, 1, we activate 2 antennas in each active blocks. And if it is 1, 0, we activate 3 of the antennas in each active blocks. And if it is 1, 1, we activate all the antennas in each active blocks. So let's see an arbitrary example here. For example, for this case, as you can see here, the B&M bits is 0, 1, so it means 2 antenna blocks active, right? And the A&M bit states that 4 antennas in each block will be activated because this is 1, 1. So if we come back to our figure here, 0, 1 means B1 and B2 will be activated, and 1, 1 means 4 antennas in each block will be activated. So I will activate this 4 for the B1, and I will activate this 4 for the B2. So at the total I will deploy 2 blocks, and at the total I will deploy 8 antennas for the case here 0, 1, 1, 1. As you can see, the active antenna pattern will be the first 8 antennas will be active and the rest of them will be inactive. Let's see an example now. Assume these data sequence is our incoming bits. So for 4 antenna blocks and 4 transmit antenna containing antenna blocks, we are going to be using 2 bits in each B&M bits group and A&M bits group. So if this first bit is 1 in the B&M groups, B&M bits group, we are going to be deploying this 1, 0, which means 3 antenna blocks. And here in A&M bits group, we'll look at this couple, which is 0, 1. So this means that we are going to be transmitting this one here by 3 antenna blocks and 2 antennas. So similarly, we transmit this 0 from 4 antenna blocks and 3 antennas in each active block, and this one will be transmitted by 2 antenna blocks and 4 transmit antennas in each block. We can see this here on the figure. The transmission of 1 is from 3 blocks and 2 antennas. Let's see. Transmission of 1 is from 3 blocks, B1, B2 and 3, and 2 antennas, as you can see here. 0 will be transmitted by the 4 blocks and 3 antennas. Here all the 4 blocks are active, and each 3 antennas in each blocks are activated to transmit the 0. Similarly, the 1 is transmitted by the 2 blocks because it's a 0, 1, and 4 antennas in each active block. So 2 blocks and 4 antennas, B1 and B2 active, and T1 till the T8 is activated for the transmission of the 1. So after the transmission is completed, the MIMO receiver gets the bits and demodulates the antenna number bits, main bits and block number bits separately, and we can achieve the transmission of the reception of the transmitted bits. So another thing here that we need to emphasize is the adaptive antenna selection feature of the multiple MIMO-ANM, which is inherited from the antenna number modulation. Within this part, the main advantage of the multiple MIMO-ANM system, which is the ability to make antenna selection channel dependent as well as the data dependent, is submitted. So if we look at the same example, we separate these 3 groups in the same way, but the transmission of these bits will be achieved by different blocks and different antennas. So if we look at this table here, we have antenna coefficients for each antenna. For T1 till the T16 we have different antenna coefficients. So we start with taking their absolute values as in the stated in this column, and these will define the quality, the data transmission quality of each antennas, and each four of them will create the coefficient of the blocks. So we basically collect them, and the acquired result will define the coefficient of the blocks. Basically, these four will be collected, and we acquire this one. This four is collected, and we acquire this one. This four is collected, and we acquire this one, and this four is collected, and we acquire this one here. And in this similar way, we take the absolute values of these values for G1, G2, G3, and G4, and we come up with these results. So the highest value here will define which data block, which antenna block is going to be selected first for the data transmission. And in each block, the highest ranked antenna coefficient will define which antenna in the active block will be activated first. So in this case, if we start with the absolute values of the block coefficients, we can see that the rank is from the B4 and B3 and B2 and B1, which means that we're going to be activating the B4 first and B3 second and B2 third and B1 at the last. And if we come back here BNM bits is 10, which means that we are going to be activating 3 antenna blocks. So this antenna block activation is going to be like B4 and B3 and B2. We're not going to activating the B1 because it has the lowest block coefficient value. And the antennas will be like what? 0, 1. 0, 1 means 2 antennas in each active block. So this is the best block. So let's start with this one. As you can see here, the highest channel coefficient value here is the TX15, and then it is TX14, and the last one is, sorry, the third one is TX13, and the last one is TX16. So we are going to be activating the 15th and 14th for the block 4, and for the block 3, if we look at the table here, you can see that the TX11 and TX12 offers the highest channel quality for the B3 block. So we are going to be activating the TX11 and TX12, and for the B2 block here, the TX7 and TX5 offers the highest channel quality. So we're going to be activating TX7 and TX5 for the B2 block. So this is the transmission of the 1. In the similar way, we are going to do the same thing for the 0 and for the 1. and after all, the result is gonna be like this. As you can see, for the transmission of 1, we activate 3 blocks, but these blocks are ordered from the highest channel quality to the lowest channel quality, and for the as the best antenna block we choose B4, and we deploy TX15 and TX14 as the transmitter antennas for the B4. For B3, the activated antennas are TX11 and TX12. For B2, these antennas are defined as the TX5 and TX7. For the similar way, we transmit the 0. We choose the best antenna blocks here, but this is here, as you can see, this is 1-1, so which means we are going to be activating all the blocks, and it is 1-0, which means we are going to be activating 3 transmission antennas for each block. So we choose the best ones. For this case, this is 1, 2, and 4 in the first block. It is 5, 6, and 7 for the second block, 9, 11, and 12 for the third block, and 13, 14, and 15 for the fourth block. And here, for the transmission of 1, we will be deploying 2 antenna blocks and 4 antennas in each block. So the best antenna blocks, as we said earlier, are the B4 and B3. So we are going to be activating these 2 blocks, and since all the antennas are going to be activated, there is no matter the channel qualities here, so we basically activate them all. By this scheme, we come up with some simulation results. As you can see here in the figure 7, you can see that the multiple MIMO-ANM scheme achieves much better spectral efficiency and bit error rate results than the other schemes, like the antenna number modulation scheme with adaptive antenna selection or without adaptive antenna selection. And the figure 9 shows the theoretical calculation results of the multiple MIMO-ANM scheme under the BPSK modulation conditions. And the figure 8 shows the simulation results of the multiple MIMO-ANM scheme, again under the BPSK modulation conditions. So as the conclusion, in this paper, MIMO-ANM scheme is proposed as a new data transmission method. Massive MIMO-ANM creates an opportunity to deploy a new dimension, which is the number of antenna blocks in addition to the number of antennas, to convey extra data bits besides the transmitted bits by the antenna number modulation and conventional MIMO PSK QAM samples. The advantages of the MIMO-ANM over conventional MIMO-ANM is the lower bit error rate performance and higher data rate, in addition to the lower complexity and ability to make not only the best. Thank you for your time. See you. And these are my references, by the way. Thank you.